Dr. Kathleen Carley is a professor in the Software and Societal Systems Department in the School of Computer Science at Carnegie Mellon University. She is also the director of the Center for Computational Analysis of Social and Organizational Systems, also known as CASOS. So Dr. Carley, thank you very much for joining this interview today. First of all, can you please tell us a little bit about your background and the research areas of your interest?
Sure, well, I'm happy to join you. So, as you mentioned, I'm a professor at Carnegie Mellon. My background is I have a PhD from Harvard University. I did my undergraduate work at the Massachusetts Institute of Technology. And my work is really in kind of computational social sciences, because I've always tried to apply cutting edge, computer science techniques and network science to, complex social problems.
Yeah, amazing. So we've also read that one of your research interests lies in dynamic network analysis. Can you explain what it is and what it is used for?
So dynamic network analysis is very cool. It's looking at the world in terms of, kind of holistically, in terms of how everything fits together. And you think about things in terms of what we call nodes, like each person is a node, or each animal, or each, idea, or each belief, and the connections among those. So like who believes what, who says what, who talks to whom. And that makes it high dimensional because you have multiple kinds of nodes, multiple types of links. And we analyze those, the pattern of those relationships and how they change over time to begin to understand like what's happening and how people are evolving, changing, and thinking about the world. So you can imagine you have that kind of data if you're in social media, because I can pull up, messages and see who is talking to who, but what are they talking about? And then see how that whole pattern changes and how, for example, does it get more excitement and more integrated and more links the closer you get to a protest? Does that go away as you get further from a protest and things like that?
Mm-hmm. Okay. So I've also read that dynamic network analysis is somehow related to social network analysis. Can you please explain the difference between these two terms?
Sure. So social network analysis, which is an academic field that started before World War II, even before computers, was
Wow.
basically focused on who talks to whom. Literally, it's just people and connections, or places where you can infer who talks to whom because you both go to the same parties or something like that. And so the difference to the dynamic network analysis is simply we have more, instead of just one type of node, we have many, many types of nodes.
Mm-hmm.
Instead of one type of relationship, we have many, many types of relationships.
Mm-hmm.
And in social network analysis, we usually would just take the data collected at one time, maybe get two, and then analyze it, with our network graphical methods. But in dynamic, we may have hundreds of time periods.
Mm.
So in some sense, social networks is kind of like a part of dynamic networks.
All right, all right. That makes sense. So also, since the main theme of our project revolves around the field of artificial intelligence, would you like to talk about AI in the context of social network analysis?
So AI plays a role in many different ways. One part is that a lot of AI as a model of how the brain works and how people are thinking, when we use it for modeling people, each of those people would be kind of standalone. They'd be individual and separate, right? So I could build a pretty good AI model of someone doing something like lifting up a cup and taking a sip of tea. But the real world is social. We all interact. So we use social networks, and with it as a way of, we literally build networks as conduits connecting the things that one AI says to what another AI hears. And so they can send messages back and forth and form their own social networks. So that's one way we use it. The other way we use it is, let's say that we're trying to understand why hatred grows, and to identify where can we stop it. Can we convince people not to hate another group early on, before it gets out of hand? And we use the network analysis to identify the groups, and even to identify where there might be hate, where there, to collect what data we need. But then we would use AI to build a hate detector on the content of what they're saying. And it would say, oh, these 10 people here are expressing hate. These 5 people over here have the features that may be that they're vulnerable to becoming people who hate. And then we would use network analysis to say, okay, where could we intervene and kind of make sure that the vulnerables get other information and don't start hating the other group. So that's an example of how they're used together.
All right. So are there any challenges with implementing all of this, implementing AI into network analysis? Just like you mentioned, you try to identify the emotions people are having. As far as I know, it's called sentiment analysis. Is that right?
So sentiment analysis is one aspect of studying and looking at emotions that's really typically used to mean I read a message or a paragraph and I give it a score, positive or negative. And most sentiment analysis is based on the presence or absence of positive or negative words. So if I say I like my little brown dog, it's going to come out as positive sentiment. Whereas there's another type of thing that also looks at emotions, which is you have about something like, is this someone who believes in climate change, or is it a climate change denier? Okay, and that's also in a way using emotions, but rather than just looking at words, it looks more at the content in the situation. So I can actually say, I hate that ice caps are melting, which is a negative sentiment, but it's a positive stance with respect to climate change.
Yeah.
Okay. And then the third way in which emotions play into this is looking at, if you read a message, what does it do to you as a reader? Or when I send a message, what does it say about my emotional state as a sender? So for example, when you're really excited, you tend to do things like use more exclamation marks or more capital letters, or you tend to use shorter sentences. And as a reader, if you see something like, and it could be words or it could be images, you see a picture of a cute little kitten and you go, oh, and it makes you all warm and fuzzy inside, So there's that emotional, like cue detecting the cues that tell you the emotional state of the subject or the reader. The latter is, well, we actually use AI for all of it, but the latter is one of the places where we're right now very focused, because it helps us understand and decide whether the link between two people is positive or negative. Am I expressing things that will make you happy or will make you angry? Now, if you go back and then link that to AI and the work that we're doing, we're bringing in all of that all 3 of those kinds of things to try to determine whether or not, like I said, the links are positive or negative, and whether that's true for the group as a whole, and then what will be the impact of sending new messages through the network. And so the hard things are there's so many hard things that are hard still. One of those is, let's imagine that I would like to do this at scale, and I would really like to get every Facebook page, right? And understand from that, just overall in Pakistan versus in India versus in Russia versus in the United States versus in, Mexico, you know, are people, worried about climate change or something like that? Well, that means I have to be able to run all the techniques that have been developed in lots of languages, right?
Right.
At least the 40 major ones in the world, but doing things in multiple. Right now, most tools only work in the language they're trained for. So while network analysis can handle any language, it's because it's language agnostic, it doesn't use the language per se.
Oh.
AI is very language sensitive because it pays attention to the words.
Mm.
And because it's trained, not just algorithm. So one of the big hard things is getting things that work across many languages. Another big thing is getting things that actually process images correctly and decide whether or not, what are the emotions present in an image and how strong are they and so on. And then therefore, does the image, kind of contradict what is being said? So you may have gotten a message that says fun times, and then the image is something really horrible. And you know that the person's being sarcastic. Well, we have to be able to analyze the image to know that. But humans are really good if they just look at it. So those are a couple of things that are really hard. We're getting much better at doing things at scale. All you need, it's like you just need a big enough computer. So,
Okay, that's interesting. So, what about the data that you collect? Do you collect the data through social media networks like Instagram, Facebook, and everything? And so while doing this, what can you say about the privacy of people?
So first off, we don't collect private data. We collect, like in Facebook, we only collect public facing data. So they've already made it public. So that's one thing. We also collect newspaper data. And Twitter, before it became X, was all public data. So we've never collected private data. If we did get permission and we're able to collect, because we're under at least internal review board, so everything we do has been studied for its ethics before we ever started. But if we were able to collect individual private data, it would be done in such a way that the individuals were not individually identifiable. And we would report only summary statistics like averages or things like that. So in that way, to help maintain their individual privacy. And even with Twitter data, we went one step further, which is that when we gave examples of tweets, they weren't the real tweet, they were a paraphrase, and the name and the personally identifiable information had been changed. So they were as though that kind of person did it, but we made it up. Now with companies, we don't remove that stuff because we don't view them as private, right? So if, the New York Times or Russia Today wrote something, we would just say, this was Russia Today, this was New York Times.
Okay. So we have also read that you have established a scientific field called social cybersecurity. Can you please talk about what it focuses on and what makes it different from traditional cybersecurity?
Sure. So social cybersecurity, which has been recognized by the American National Academies as a new area of science, is concerned with keeping the internet open and available for people to go about their business, communicating, playing, interacting without fear of undue influence, and the technologies to make that happen. So where cybersecurity is very much focused on hacking machines and on attacks on machines or attacks on data. Social cybersecurity is about influence and affecting people and affecting groups. And the skill sets you need in the two are quite different. In social cybersecurity, you need some AI training, you need some social science training, you need some graph theory, statistics, and so on. Cybersecurity, you need to understand how the core of the machine works. So you need real hardware understanding. You need some algorithm design, and it's just like a different kind of core set. So even the sub-branches of statistics are different, and they almost never use graph theory, whereas we use it all the time in social cyber. So those are kind of the big differences between them.
So can you please tell about the problems that you are trying to solve through social cybersecurity?
So one of them is disinformation or misinformation. How do we detect it, and how can we stop it from becoming viral? When do we need to bother to worry about it? Because there's lots of stuff out there that's incorrect, that it's like it's here today, gone tomorrow. It doesn't do anything, right? Nobody cares. So disinformation is one, hate speech is another, online extremism and recruitment to online extremists is the third one. Insider threat, where people recruit people to steal information from companies. And brand safety, like if you were to we're a company and you had a particular brand, or you were a person and you had your personal reputation, how do you maintain the safety of it so it doesn't get harmed?
We've also read that some of the problems that you are trying to, solve through social cybersecurity are, the factors that play a role in disinformation, bots and trolls. Can you please talk more about them?
Sure. So bots are completely automated accounts that can, once they're set up, the human can go away and they will do various things. They'll do various kinds of jobs for you. Whereas a troll is a human operating under a pseudonym who is purposely trying to disrupt a group, and often employs the use of hate speech or what we call identity bashing. Like they're always talking against women or against LGBTQ or against Africans or whatever. So one of the things about bots is there's a lot of bots. They occur on all platforms, also all different social medias, and even things you wouldn't necessarily think of as social media, like GitHub. And a lot of them are very, very useful, right? They announce that a new product is available. Or like in Indonesia, they warn people that a tsunami is coming so people who are on social media can get to safety. But the same kind of bot that can be used for good can also be used for spreading disinformation or for introducing people together. And what we see them doing in hate groups is they find individuals like, if, Auntie over here expresses hate toward dogs, and Joe over here expresses hate toward, cats. Then what they do is they introduce the two of them together. Say, you guys, both hate these animals. So you should form a hate animals club, basically. And then they form these groups that are groups of haters. And then they change what they're hating. Say, okay, now instead of hating those, why don't you all hate scientists? Because scientists are the root of all evil, and so then they switch them to that. So bots play a big role in creating and shaping the way people work in social media. But like I said, they also can do good things. So don't just kill the bot, don't just ban the bots, as they say. And trolls, like I mentioned, are people. There's also these new accounts we're finding called cyborgs. And cyborgs are accounts that are sometimes bots, but sometimes people. So it's the same account. And so let's imagine that you're an activist for something like, I don't know, some kind of like eco activist, right? You'll sometimes get on it and play it as a human and get everybody in your community to think about something. And then you put on a bot to just keep amplifying it and go away. Then you come back, a month later, switch it over to a new topic, and then put it back on the bot. So we often find things like celebrity accounts or activists. And there seem to be some other kinds that will often look like cyborgs, or part of the time it's definitely run by just completely automated. But other times it has all the nuances of being a human. But our new generative AI models are making this much more difficult to distinguish.
All right. So can you tell us about the usual motivation behind acts of disinformation? Why do people do this most of the time?
So why do people spread disinformation? Okay. For a variety of reasons. Some people spread it because they think it's funny. And they want to just see what it'll do. Like there were these kids at a Manchester football game in the UK, and they spread on those saying, "Hey, my little brother's lost. Could you help us find it?" And it wasn't their little brother. It was just the poster child for autism. They just thought it would be funny. Other people spread it because a lot of people spread disinformation not knowing it's not true because they're really trying to help someone. So we saw a lot of people spreading what they thought were cures for COVID in the early days of COVID because they thought it might help, right? And it was just, so we often refer to that as misinformation. Other people spread it because they're trying to make a point. So a lot of people who just could not stand Hillary Clinton would send out disinformation about her, knowing full well it was not true, but just say, "I hate her so much, I want to let you know this," kind of thing. Other people spread it for money. There are groups who are paid to create and send out disinformation. In other cases, disinformation is spread by nation states themselves to try to establish their position or to counter another country. So like during COVID, there was this one bot and this disinformation campaign that was run by China that said that COVID was invented in this one military lab in the US, brought to China by our soldiers, and then to a war game, and then let loose on the world. Complete disinformation. And they started to spread it by one of their state sponsors' account and by the bots that then passed off of it. So lots of different kinds of reasons, from political to monetary to just people trying to have fun.
So how can we detect the acts of disinformation? How can we detect trolls and bots and cybergs? Are there any guidelines for doing this?
Well, so cyborgs are accounts that are part of the time bots and part of the time humans. So you need something that can detect bots, and you run it on all their messages. And if you see it going body, 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 not a body, not a bot, not a bot, then you can tell it's a cyborg. Trolls, you have to be able to detect hate speech. So you have something you're looking for, and you have to have data that has been somehow either labeled or that you have a match function for training it in your AI system. And then you build a model that captures those kind of features, and then you run it on your other data. So like for bots, there's so many kinds of bots. We actually have many, many different bot detectors that detect different features. Like these detect whether it's chatting a lot. These detect whether compared to a human, it's been in so many locations that it is not physically possible for a human to be there, or that it's literally typing too fast, faster than a human can type. And so you check for a whole bunch of those kinds of features. You have a whole bunch of things so people have said, yes, it's a bot. You train your model, and then you set it loose. But by having a lot of these different ones, we have what we call an ensemble of experts system, where it has lots of different experts, these little AI tools, and they each look for different features. And then we say, wow, a lot of them are true, it must be a bot.
Mhm.
But it's probabilistic. It's not a guarantee that it's a bot. And the same with hate speech. And hate speech, again, we have lots of corpi that have been human coded as being containing hate. And then we build our models.
Mhm. So,
We can get a little bit better using social science theory, by the way.
okay. So since we talked about trolls, I was interested, why trolls? Like, why do we call them trolls?
Um, the reason we call them trolls is because they would join these groups and start trolling for someone who they would start trolling like fisherman mode, looking
Mm,
for someone who was vulnerable, and then they would find someone who's vulnerable, and they would start picking on that person with nasty messages and hate speech and so on. Kind of like in the old Nordic stories of trolls under the bridge,
mm,
kind of causing problems.
mm. That's interesting. So we've also read that your team at CASOS deal with complex real-world issues through the combination of computer science and social science. Can you please tell us about what sort of problems you're currently working on? What sort of projects?
So currently, well, first off, it's a big group. We have over 20 people. Um, and we're working on how do we counter disinformation, which it's there. We're working on identification of pink slime sites. Pink slime are sites that pretend that they're local newspapers, but they're really not. They're actually something set up by a rich conglomerate or by another country to try to get people in that region to believe something. So how do you find pink slime sites? Were new mathematical techniques for detecting hidden linkages, like knowing that there's a tie between you and some other people, even though you don't make it obvious. Can we find those hidden links? So which helps us with our work in counterterrorism and things like that. Um, we also have a huge project on developing a system for creating not just synthetic data, but synthetics, an entire synthetic scenario for training people in influence operations, influence campaigns, disinformation, and so on. Where it's our ASOP system where you basically say, I want to run an exercise with my students or whatever, where they're seeing it's as though they're in a pandemic set in 2080, and at the same time that that's going on, um, Zimbabwe has decided to send a bomb at its nearest neighbor, and they're down in that part of the world, and so on. So it generates, and there's these five main characters and all these peripherals, and here's some of the big storylines, and you kind of give it the outline for a story, and then it generates all
Mm,
the details that are needed to give to something like a chat GPT tool to then generate synthetic tweets and Facebook pages and news pages.
mm,
And that gives you then the data for training people on,
mm,
because you don't want to use real data because of the privacy issues, but this gives the synthetic data. So that's one of our big projects. We also have other big projects on um, identifying, extracting emotions from audio and images and combining those with text ones to better identify what kind of influence that particular message will have on an individual or a group using our BEND framework for influence campaigns. And then we have that links into a whole project we have on the next generation of hate speech detectors. We just finished up our next generation of bot detectors.
mm.
So those are
Yeah,
some examples.
yeah. Uh, I also read a description of this project called BioWar, and I was really impressed by what you are doing there. Can you please tell us more about it? What it does?
So,
Yeah.
yeah, sure. So BioWar is an agent-based simulation model of people in a city that's to scale, to a city scale. And literally, we designed it and then we instantiated it for 3 different cities. And what that means is that we took census data and we made each of the little agents into family groups, and the family groups were similar in kind to those one would get see in the census. So if the census said the city has 30% of the people under 30, then 30% of the people in our simulation model would be under 30. And they would be distributed in a physical space like you would see in the real world. And they would go about their daily business. They would go to school, they would go to work. And if it was a Saturday or Sunday, of course, they would stay home from school. And then we developed diseases by not taking existing diseases, but by taking symptoms,
Hmm.
both symptoms that were visible to you, like coughing, and symptoms that required someone to actually do a test, like seeing if your mediastinum had been increased in size. And so that if the individuals felt symptoms that were visible, they might go to the doctor. The doctor might order one of the other tests, and we had the timing correct so that we knew how long it took to get the results back. And then we just played out different kinds of diseases through this. And we did them like on normal days or during flu season, whatever. And we used this for different kinds of interventions. And long before COVID, like almost a decade before, we actually ran studies that showed that if you just kept kids home from school, it did not stop the
Oh,
spread of a pandemic type disease,
okay. Wow.
because they treated it like every other weekend and just went to see grandma or whatever. And
Yeah,
stuff
yeah.
went all over the place. So
That
you had
makes.
to quarantine them as well as keep them warm.
Mhm.
Yeah.
These tools, I think that these tools could be very effective for governmental organization to make decisions and everything.
Yeah.
Are there any governmental organizations that are currently using the tools that you are working on at CASOS?
So some of our stuff are used with various government groups, with various public affairs groups, with various companies, because a lot of this is done by companies, right? Um, and there's ones like the things we develop, but developed by other groups that are also in use. So like
Mhm.
the BioWar kind of models are now being used by several different states to help
Mm,
them plan and respond to these kind of things.
wow. And my last question is, in what ways do you think that the progress that you're making at CASOS will change the world in the future?
Oh gosh, I don't know. We hope it changes it to make things better and more peaceful, but I don't know. I think that already has helped people understand that certain types of approaches don't work. So kind of some old ideas about how to convince people to do things are no longer as popular. Um, and it helps them better understand how important the words that are said online matter and affect things. So
Mhm. Okay. Thank you very much, Dr. Carly. So as I mentioned before, this was my last question, and we will make sure that the insights that you gave us, this valuable insight, will reach people who really need it, the AI enthusiasts in Uzbekistan, and everyone who is interested in this topic. So Happy New Year, and thank you very much once more for joining our interview today.
well, thank you so much for having me. And I would strongly encourage people who are interested to look not just at AI, but also at network science, because the two together are very powerful for doing the things you want to do.
Sure. Thank you very much.
Mhm. Take
Bye.
care.